All right, so this lesson is going to briefly go over expected value and what it is, why do we calculate it, and so have some highlighters ready to go and a pencil. So this is on page 69. So expected value, an application of probability that involves the likelihood of gain or loss, and it's stated as a dollar amount. You got to make sure you understand that expected value, when you answer it, will end up being a dollar amount. It is relevant in business, insurance, and I would say in like playing games. It has to do, it tells you whether or not you stand to gain or lose in the long run. The concept of expected value can be used to determine whether or not to participate in games, right? You can use it to determine whether or not you will participate in a game of chance or lottery or whatever. The expected value is only accurate in the long run, and it would be after playing many games, right? So it's like theoretical probability. It only makes sense on a large sample, right? So it could be you calculate this and you expect it to win, but the first couple of games are losing. Well, the idea is you keep doing this indefinitely or for a long time until you start seeing the results. Here's the formula for expected value that I have been using for a while. However, I'm going to try something different. I think this one that I'm about to give you, make sure you copy this on your study sheet, I would say, even as you're watching this. Expected value. Okay, so you have, under probability, you have a heading called expected value, and you'll have this formula there, and it will not be this one. Okay, so I'm changing it up. I think this one is a lot easier. So expected value, how do you calculate that? You take the probability of winning, let's say the first prize, that will be a number. You multiply it by whatever the prize is, the first prize, right? Like, because we could have multiple ways of winning. Let's say there are 3 prizes, right, to be had, and you want to participate. So there's a probability of winning that first one and a certain amount, a dollar amount associated with it. So if there's another way of winning, then you would continue this pattern. So you go probability of winning that second prize times the dollar amount that you're winning. Okay? And you keep on going in as many ways as there are to win. I've seen a maximum of 3, but it wouldn't matter. You just keep doing that. At the very end, right? So dot, 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 this keeps going. At the very end, you're going to subtract the cost to play. Okay? At the very end, you're going to take away that cost of playing. So we'll calculate all of that, and then at the very end, if it costs $5 to buy a ticket, then that's what you would put down. Okay? This is the formula. This is what I would like you to have on there. On your study sheet, because the formula on the formula sheet that you get, I don't have the formula sheet on me right now as I'm doing this video, but it is very different and it's not as useful. Okay, so this is what we're going to use. Now, when it comes to our answer, and I want you to have this, it can be very small underneath this formula. Okay, first of all, that expected value will be a dollar sign, okay? And that the answer, the sign is very important to us, okay? If you have a positive answer, it doesn't matter what the value actually is, okay? So example, right? If you have the expected value is positive 0.03, so 3 cents. Positive 1,200, so $1,020, etc. If it is positive, okay, if your answer on the calculator does not have a negative in front of it, that is, then you're expecting to gain from the player's perspective. So it's good for the player, but it stands to note that that would be bad for the host, okay? If it's 0, it's a fair game, you break even, your choice whether or not you're going to play. On the long run, you're going to end up with the same amount of money that you started with. A negative answer, okay, then you're expecting a loss, and that is loss for the player. So this is bad for the player, but it is good for the host, because if you're losing, the host is winning. So that's important to understand that. So example, if you had, if you calculate your expected value and it's negative 20.50 or negative 0.05, it doesn't matter. If you get a negative answer, the player is expected to lose money in the long run, but it's good for the host, okay? I would say this should be under the formula. You can make this a lot smaller, right? So you could basically have, if it's positive, right, you gain. Player gains, I should say. Right, let's make that very obvious here. Positive, player gains, host loses. Negative, okay, player loses, host gains. Like, it doesn't have to be this elaborate, okay? But just make sure you have the sign there. The amount doesn't matter, because some students calculate and it's like 3 cents, and they're like, yeah, you shouldn't be playing because it's too small of a number. No, we're looking at the sign, okay? Let's do an example and see how it goes, okay, using the formula. So you will see that word expected value, like calculate the expected value. You should immediately know you're going to go to your formula and use it, okay? There's a summer fair, and the game consists of drawing marbles, so it could be dice, or a die or dice, or cards, or you name it. It could even be a contract, like a government contract where there's a certain percentage that you're going to get the contract. It doesn't matter. There will be a percentage or a fraction that gets you the percentage in terms of probability. So a bag contains 10 marbles, 10 red, 30 yellow, and 60 white marbles. We've got 100 in total here. That's worth noting. If you draw a red marble, you win 25 bucks. That's prize number 1. If you draw a yellow marble, you win 7 bucks. That's prize number 2. If you draw a white marble, you get nothing. So that's not a prize. It's saying you wouldn't win anything. So in this case, there's only 2 ways of winning. And here it is. It's going to cost you $3 to play the game. Okay? It's going to cost you $3 to play the game. So $25 for the first prize, $7 for the second. And so 2 ways of winning here, which means if I use my formula, I will use this one, expected value. Probability of, in this case, red, okay, that we're going to multiply by the first prize. And you don't need to write this out in the future, okay? To win the second prize, you need to figure out the probability of a yellow, because that gets you the second prize, and you'll multiply it by the prize, the second prize, which is $7. So these are all going to be numbers. You're done now. So lastly, you're going to go minus cost. Okay, that's how you will calculate that. So here we go. Probability of a red one. Red, there's 10 out of, in this case, 100. So you got to be careful. Always read carefully. 10 out of 100. So that's my probability. And the prize is 25 bucks. Plus, probability of a yellow. There are 30 yellow marbles out of the 100. So 30 out of 100. And the prize is 7 bucks. Minus the cost to play is $3. Okay? So there you have it. Now you just need to be very careful with your calculator and figure it out. Please don't type this all in one shot. That usually backfires. So I'm going to go 10 divided by 100, do what's in the brackets. Then I'm going to multiply it by 25 and get my answer. So that's 2.5. Plus, I go 30 divided by 100 times 7. That's 2.1. Minus 3. That's already done. And here we go. Clear it. 2.5 plus 2.1 minus 3. You get 1.6. But make sure you put a dollar sign and you go 1.60 because it's money. Okay? That is your expected value. And notice that it is positive. Okay, the sign is positive, like you didn't have a negative in front of the number, so that's by default positive. Okay, so we're gonna say you just gotta watch out for rounding. Okay, it's money and units. Okay, gotta make sure you get that right. You need to have the 0 because it's dollars. Okay, and note. Positive answer. Okay, that is a note. Sometimes they ask a follow-up question, and sometimes all you need to come up with is the 1.60 in this case. So here are some follow-up questions. Should you play this game? Justify referring to your answer in A. And I would say yes, since the expected value is positive. That's it. That's it. If you mention that, you got the mark. It'll be worth 1 mark usually. C. If you were to play this 125 times, how much would you expect to win or lose? Well, we know we're winning because it's positive. So you would go 160 times 125 times. I have not seen them do this, but you would expect to have 200 bucks in your pocket. Okay. What about this one? Should the fair offer this game? From the fair's perspective, because as a player, positive means you're winning. Okay. So for the player, yes. Should you play as a player? No. A positive expected value means the player wins. And therefore, the host loses. Okay? So that's the idea, how to answer it. That's how you do it. Okay? Now, I want to tell you, give you a heads up. If you're watching this video and then later you're looking at the answer key, for example, if I go to page 71 here, the way I do the work is different. But your final answer will match if you do this correctly. So don't let the work throw you off. I haven't changed my key. This is the first time I teach it a different way. I think this way, the way I just showed you, is much easier, cleaner, and I think that's the way we're going to do it moving forward. Okay, so I'm going to do one more, and that way you can't say you didn't have enough examples. If you feel like you got this, you're confident, you can pause me or start working on the rest of the questions. So here we have a 6-sided die is rolled. If you get an even number, you win $3. Odd, you lose. So there's only one way to win if you think about it, right? Calculate the expected value of each game. Well, expected value, let's see here. Probability of even, if we figure out that, we'll multiply that by the prize, and then we go minus cost. That's it. Because there's only one way to win. One prize, okay? So then you don't keep on adding, because there's no other way of winning. How many even numbers are there? If it's a six-sided die, you've got 1, 2, 3, 4, 5, 6. Even. It would be the 2, the 4, and the 6. So 3 out of 6 are even. The prize is $3. Okay. $3. Then you go minus the cost. The cost is $1 each time you play. So this should give you, if you go 3 divided by 6, that's 0.5, times 3 is 1.5, minus 1, so that's 0.5, but 0.50 really positive, okay? Should you play this game? Way too much room for that, right? Should you play this game? Yes, since the expected value is positive. If you were to play 75 times, should you expect to win or lose? We're winning, so 75 times 50 cents, and that is 37.5. 37 and 50 cents that you're winning. And so keep going. I will post the key to the rest. So thank you for your time. Make sure you practice this.